Hi, everyone. I hope this finds you doing well, staying healthy, and staying safe. Last week, I released a version of Illuminated Cloud with a new refactoring for Apex that allowed you to move static members from one type to another. Static members include inner types, which are implicitly static, fields, properties, and methods. Again, they must be static, and you can move them from one type to another type, including creating the new type as part of the refactoring. I mentioned at the time that there was another aspect of this functionality that was not included in the first iteration of the feature, and that it will be coming in a subsequent iteration. I've actually finished that up, and I'd like to show a demo of it now. The new feature, the new part of this refactoring has to do with moving types, and that can be taking inner types, and by types I mean classes, interfaces, and enums in Apex, and moving them from being inside, nested within an existing top-level class, to being themselves top-level types. And conversely, taking top-level types and moving them to be inside of another top-level class. And there are good reasons why you might want to do either one of those. I think those will come up more organically as I work through the demo. So why don't we just dive in and we'll take a look at how this particular refactoring enhancement works, some of the limitations around it, some of the considerations around it, and just see how it goes. So this is a top-level class called comparators, and it actually has, in addition to having some member variables and some constants and things like that, it actually has several inner classes. And so what we're going to do is take two of those inner classes and move them to be top-level. We're going to run into some constraints along the way and show how we can identify and resolve those constraints. And then we're going to move them back in. We're basically going to do the reverse of that and talk about, again, why you'd want to do either. So we'll start with this class right here, which is a public abstract class, and it's, again, nested within, and I want to move it to the top level. So I'm going to use the same refactoring, the move refactoring that's activated through, by default, the F6 accelerator key. When I moved members, it said move members, and now it actually is contextually aware and says move inner type. So I'm going to go ahead and do that. Now, previously, what you would have seen when you start a move refactoring on an inner type is it would have shown how that you could move it to another type as, again, an inner type. But now it's actually showing you multiple options. You can do that. You can also cancel the operation, but you can also move it to the upper level. So let's go ahead and hit enter and see what happens. So it is showing me that if I were to try to take this class as is and move it to the upper level, I would actually end up in a broken state. If I tried to deploy, I would get errors from the compiler, in this case from the reference validation. And so Illuminated Cloud is going to verify referential integrity both with inbound references and outbound references. So let's just take a look at what it's saying here. So it is saying in this case that there are member variables inside the class I'm trying to move up. This is the class I'm trying to move up. There are private member variables that if I move that to the top level, they would no longer be visible to some of their usages that are not in the class I'm moving up. And that's because private, in this case, is still accessible to other inner classes in the same top level class, including some subclasses of this. And so I really have two ways to resolve this. I can either make these a higher visibility, say protected, which would take care of subclasses, or I could encapsulate access to these. And I actually have some accessor methods that I can use to do that. So we'll go ahead and just change that to use the accessor methods. And that will allow us to hopefully try this again and have it work. So let's redo the refactoring and say we want to move to the upper level, and notice that the errors do not come up, and it has actually created a new top level class called configurable comparator. That was what we started with as an inner class. I'm going to add that to version control. And if we take a look at version control, we can see that that class was removed from comparators as an inner class. It was added as a top level class. And of course, references were updated. So this was a scoped reference where it was referenced as an inner class, and now it's referenced as a top level class. So it took care of everything. And if we save now, it should save everything successfully. And it did. So that was pretty straightforward. Let's do another one that will show a different set of considerations. So we'll go to SObject field value comparator. Now, one thing I want to point out is this is a private inner class. This is taking advantage of the fact that we can use a top level class to provide encapsulation for some functionality inside of that that is only ever used and should only ever be accessed by and exposed to other functionality inside of that same top level class. So that is a nice feature of Apex, and it is one of the very few options that are available in Apex for doing lexical scoping, hierarchical lexical scoping. More on that in just a moment. So let's go ahead and try to move this to the upper level. And once again, we're going to see a set of issues. Now, I mentioned earlier that there were inbound references that would have been broken by moving configurable comparator, the other example, to the top level. Well, these are outbound references. So in other words, the class that I'm trying to move, SObject field value comparator, has references to constants in the parent class that are private. Now, they're test visible private, but they're private. And so because the class I'm moving is not a test class, and I'm moving it to the top level, it would no longer have visibility into these. Now, for the moment, what I'm going to do to resolve this is I'm going to make these public, and you'll see why as we go through the use case. And I'm going to go ahead and save that so that that is made clear. And then I'm going to cancel that, and we'll go to SObject field value comparator, and we'll restart and move this to the upper level. And this time it was able to do so. We see the same dialog of adding that to version control. And if we go, and another thing I want to point out is the visibility was promoted from private to public because you can't have a private non-test top-level class or top-level type. You also can't have a protected top-level type. So it had to promote to at least public. Now, if this was already public, if it was global, it would retain that. But in this case, it went ahead and promoted it from private to public so that, again, relational integrity would hold up. And so let's take a look at what's happened now. And so comparators, again, this is a change we made manually. This is where it removed configurable comparator in the first refactoring. These were the changes we made to those fields for access to be instead through accessors. And then here's where the SObject field value comparator was pulled up to the top level. And let's go ahead and save. You can see that it's saving a couple of different references in order to make everything whole on the org, and the org is now updated. Now, one interesting thing about those two constants is that they were only ever used by the test, they're test visible, and by the inner class, which has now been moved to an upper class. And realistically, if inner classes in Apex could allow static members, they can't. If they could, this would have been nested within that inner class, these two constants, again, for proper encapsulation and proper coupling. But instead, instead they had to be declared and defined in the top level class because it's the only type of class that can contain static members. So why don't we go ahead and move these to our new top level class. And once moved, you can see that Illuminated Cloud is telling you that a test visible symbol should really only be used on something below the public visibility level. So we'll go ahead and change these to private using the quick fix. And we'll go ahead and save that. And we're back to a proper encapsulation. And if we look at the bottom, the save went fine. Okay, so that was moving things to a top level. The primary reason you'd want to do that is perhaps you were developing with using inner types as you were fleshing out some behavior. Maybe you're using the ability for Illuminated Cloud as you're typing out an unknown type name, an unknown identifier name, to actually stub that out for you as inner types. And then you realize you want those as top level types because they're more broadly applicable. Why would you want then to do the opposite, and that is to take a top level class and move it to be an inner class? Well, I think we motivated this rationale earlier, and that is encapsulation. As I mentioned, the capabilities for Apex to provide hierarchical lexical scoping are very limited. Most other modern languages have some concept of namespace or package as a language level feature that allows you to scope an identifier by some other path, and it will not collide with that same name at a different path. The fully qualified unique name is based on the namespace or package and the name. Now, Salesforce does have a notion of namespaces. They're very tightly coupled with packaging. Packaging is really its own thing and has its own weight associated with it, and that's not what you should use for just general lexical scoping when you're doing development in Apex. So the only mechanism that's available is inner classes and members inside of a top level class. And that can provide encapsulation through visibility. For example, we saw that some of these inner classes were private and therefore could only be accessed from other members of the same class. It also keeps you from polluting the global namespace. So by moving configurable comparator and SObject field value comparator to the top level, effectively I have made these the only types with those names that will be allowed in this organization. So if you tried to take multiple projects worth of metadata and deploy them into an org, you could potentially have conflicts where somebody else named something configurable comparator. By nesting that inside of the comparators class, I give it a more qualified and unique name, and therefore minimize the risk of collision in the global namespace. So just avoiding global namespace pollution is another major reason that you'd want to do this. And given the limited capabilities of Apex in terms of hierarchical lexical scoping, it becomes an attractive and useful option. And that's why this part of the refactoring about show is so valuable, because if we find that we're only using things inside of other things, or really they could be logically nested within those because they serve a similar or related purpose, then it's nice to be able to just move those one type to be basically nested within another. So we'll do that. Now, before, with the top level type, if you had said you wanted to do a move refactoring, it would have allowed you only to move it to another directory in your project or in your file system. So basically to restructure your project directory structure. But now, as we showed with the move inner to upper, it has multiple options available, including move to another class, which is going to prompt you for the new parent class. So we'll go ahead and say comparators. It has code completion here. It also has history, so you could choose something from a history, and we'll go ahead and say refactor. And it's going to move that. Now, this dialog may be familiar to you if you've used Apex's, the Illuminated Cloud's Apex rename refactoring, and have used it on a top level type or a top level trigger. And the reason that this exists is once you've made those changes, you need to deploy all of the new metadata with all the relational changes and things like that to remove all the references to the old name, and then you can delete the old name. And so that's exactly what we're going to do here, is deploy and then delete, and it's going to bring the org up to date. Now, that's optional. You can turn that off in the config options by turning off propagate local deletes and deploy on save, but it'll help you keep the org up to date as you make changes locally. So I've moved that back into the comparators class, and let's do the same thing with SObject field value comparator. Now, I didn't get the multiple options when I said I wanted to move this one. I can only move this like I could before in the file system. And the reason for that is, I mentioned earlier that inner types cannot have static members in Apex. There's a couple of restrictions in Apex. They can't have static members. And then as effectively, kind of a secondary consideration off of that, they can only be nested at two levels, top level and one level of inner. And the reason for that is an inner type can't have an inner type because inner types are implicitly static, and an inner type can't have static members. So basically, you can only have two levels of nesting. You can't have static members. This has static members, so it's not offering that option. So let's move these back into the top level comparators using the move members refactoring, and they're moved back. And we'll go ahead and you can see at the bottom I'm saving, bringing the org up to date. And then what we'll do is go ahead and move again, and now it allows us that option. So we'll go ahead and move this into comparators as well. And it's going to give us the same option to bring the org up to date. And it's deploying, and everything looks good. It's deployed, and now it's deleting. And I'm going to go ahead and save everything. And we can see that everything saves fine. We can restore some of the encapsulation we had. And the only difference that you'll see if we look at version control is it re-added the classes at the end instead of where they originally were. In fact, I'll just bring this up in a more first-class manner. So these were added at the top instead of being right under this commented out area. These two were added at the bottom, so you can see they were moved to the bottom. And then, of course, the other small changes we made in order to allow ourselves to do the move from inner to upper. So, but otherwise, it is functionally the same code. You could do whatever touch-ups you wanted to, but it is functionally the same code. So what you've seen is that the move refactoring for Apex now allows you to not just move static members, excuse me, from one type to another, but also to move static inner types to be top-level types and qualifying top-level types to be inner types of a class. So altogether, that should allow you a lot of flexibility in terms of reorganizing your code base, not having to worry about all of the minutia of what it means to touch up all of the references, to bring your org up to date, things like that. So that's what I wanted to show in the demo. I say this every time I show something with a higher level of complexity like refactoring. There are almost certainly bugs. I've tested this extensively. There are almost certainly bugs. If you find bugs, if you find things left in a bad state after the refactoring, if you find false positives or negatives on some of these validations it does, just open an issue in the public issue tracker with a clear reproduction. I'll take care of it ASAP. I want these to be extremely, extremely reliable and to result in a proper state at the end, and just become part of your ongoing workflow for constantly improving and reorganizing your code base. Otherwise, I hope you find it useful, and thank you for your time, and I hope everyone stays well and stays safe. Thank you very much.